Okay, so we are now going to learn what we need in order to answer that question that we had with our space adventures problem. So you will remember that our trig ratios, sine, cosine, and tangent, and we learnt this acronym SOHCAHTOA to help us. So the first part tells us that sine is equal to opposite over hypotenuse. And the second part tells us that cosine is adjacent over hypotenuse. And our third part, tan, is opposite over adjacent. So something we're going to use to help us in this unit or in this section is what I call the cast diagram. So remember we were talking about the Cartesian plane. So in our Cartesian plane, we end up with 4 quadrants. And so within those quadrants, we will have different rules regarding which ratio, sine, cosine, or tangent, is going to be positive. And for now, we just need to know what's going to be positive and what ratio. We're not going to get into why. You will understand that when we get to graphing trig functions. So for now, we just have to understand within our Cartesian plane what is positive and what is negative. So we start down at C. So you'll see now why it's called a cast diagram. So cosine is positive there. Everything is positive in that quadrant. Sine, so there's my S, is positive in this quadrant, and tan is positive down here. And that's where we get our cast diagram. That's why it's called a cast diagram. So right now, these two things that I have up there in the front are what we're going to be using. So I like to call that our little toolbox. What we're going to need when we are answering any of these questions. So we're going to use this example here, where I've given you a point on the Cartesian plane. And I'm going to just name this angle theta. So what we have is we've got this arm, and what we call this arm is we can call it terminal arm. I like to call it a radius or a radial arm because it represents the radius if we had a circle that went around with this point on the circle. Okay, so that's why I prefer to call it a radial arm, but you'll see it called a terminal arm. Sometimes they won't call it anything. But so this is called R because it represents the radius. Now this distance 3, this is my X value. So it is how many units I had to move this way. So if I drop down a perpendicular to my x-axis, I know that this is 3. So that length is 3. And I know that this distance here, which is my y value, that is going to be 4. So from here, I can write out all 3 of my primary trig ratios. We're not going to look at the secondary and reciprocal ones today. We're just going to look at our primary trig ratios. So we have sine of theta, and this is opposite. So remember, we have to go opposite the angle. So that is 4 over hypotenuse. And now we have, what is my hypotenuse? My hypotenuse is r. I can't say r. So what we're going to do is we're going to use Pythagoras to work out the r value. And so we get r is 5. So that is sine. Cosine, we know that cosine is adjacent. So this is my adjacent is 3, and my r value is 5. And then we have tan, which is opposite, which is 4, over adjacent, and that is 3. So just from this example, let's see if we can come up with some steps. So what was the first thing? The first thing was plot the point and draw the, you can say radius or terminal arm, whatever term you like, that's what you're going to write in there because these are your notes. And then what we did was we dropped down that perpendicular to create a right angle triangle. And then we determined the length of the unknown side using Pythagoras. So those are your key steps. So before we move on to more examples, let's draw in our diagrams. So if we had our triangle there, then this is y, this is x, and this is r. So then the definition of sine, in as far as my Cartesian plane, it's still opposite over hypotenuse. It's just my opposite is a y, and my hypotenuse is r. So we're just taking what we already know about these trig ratios and their definitions, and we're just applying it to a triangle that is now in the Cartesian plane. And I want you to remember to have that right angle sign. We do need that there. Oh, I'm in purple. There we go. So we have x and y, and that is my r value. So now cosine is x over r. And then our last one was tangent. So again, so tan is then opposite, which is our y value, over adjacent, which is our x value. Okay. So in these diagrams, we've just drawn everything where x and y are positive, but that's not always going to be the case. And this is where Cartesian plane angles and Cartesian plane trig ratios are different from just a plain two-dimensional triangle drawn on a page. Because a two-dimensional triangle drawn on a page, all those measurements are positive. But on the Cartesian plane, depending on where we are, you could have a positive x value, you could have a negative x value. You could have a positive y value, you can have a negative y value. The only value that always stays positive is the radius. Because and that helps to think of it as radius. Because if you think of it as the radius of a circle, then radius can never be negative. Okay, so that helps with making sure that you never give a negative to your r value. Okay, so let's look at this example here. Given cosine is negative 12 over 13, where theta is between 90 and 180. So this is important because remember in our cast diagram, for cosine to be negative, it could have been here in this quadrant, because only sine is positive here, or it could be down here. But they've told me that theta is between 90 and 180. So I just want to explain to you the way our radial arm works is it starts here at a 0, okay? And then it'll move in that direction, okay? So that's the direction that we rotate from. So this is 0. And if I get up to here, where am I? Correct, I'm at 90. And then down here, 180. Down here, 270. And then if we come all the way back up, we're full circle. So we are 360. Okay, so that's going to help us because we will be given a range sometimes of where our angle lies. So here they've said we are between 90 and 180. That means I can't be down here because this is past 180. So I have to be up here. So we're going to draw our terminal arm and draw our 90-degree triangle. And we are given cosine. So that's x. So x is negative 12. And r is 13. So we have to figure out our y value. So our y value, we're going to use Pythagoras. And we can see that in this region, y is positive. So we're going to have a positive answer. And we're going to use Pythagoras. So we are going to say 13 squared minus negative 12 squared. Make sure you have your brackets there. Otherwise, it's just all going to go wonky. And when we put that into our calculators, and I want everyone to have their calculators out, I want all of you working this out together so that you all know that, yes, you are using your calculator correctly. All right, so we will get 5. If you did not get 5, please double check what you've put into your calculator. You might have forgotten brackets. You might have put the square in the wrong place. All right, so we have y equals 5. And so they wanted tan of theta. Well, tan of theta is 5 over negative 12. But we don't say, or we don't ever put the negative in the denominator of our fraction. That negative should be written at the top. So please make sure that you are doing that when you give your answer. Okay, if you need to write it first like this and then go to here, that's fine. But you must end up with this. And some of you might just be able to give this final answer right away. That's perfectly fine. You don't have to show the 5 over negative 12, but you have to get to the negative 5 over 12, okay? Because that's just proper math. Okay. So I did mention this earlier, this warning that the sign of x and y depends on where in the Cartesian plane the terminal arm lies, or the radius lies. So let's look at this example. Now in this one, instead of being given just the trig ratio, we're given a trig equation. So we have to do some work here. We have to isolate our trig ratio. So if I isolate this, meaning I just want the trig ratio, so sine beta, then I will have to divide by 17. So negative 15 divided by 17. Okay, so we have that. Now, this example looks like what we've had in the second example, where I've given you a trig ratio. And so they have said, draw the right angle triangle in the correct quadrant. So to help us, we are going to use our cast diagram, and we are going to look at the range that they gave us for our angle. Well, we want sine to be negative. And for sine to be negative, I could be here or here. Because in those regions, the only thing positive are tan or cosine. So I know that sine's going to be negative in there. But they've told me that I am between 90 and 270. So my angle has to fall in here, which means the only quadrant it can be is over here. So we're going to draw our radius. Pull up to create my 90 degree, and that's important. You never go across to then your perpendicular that you draw will always be perpendicular to the x-axis, not to the y-axis. Okay, so just be very careful when you're doing that. And that's why the drawing of the diagram is very important. All right, so we have sine. So sine, the y value is negative 15. The r value is 17. I need to find my x value. So I'm going to have x equals, and in here, this is where, again, it's that whole watch out. Before you go straight to using Pythagoras' theorem, if you are solving for x and y, look at your diagram so that you can see which quadrant am I in. Will my x be positive or negative? Will my y be positive or negative? The only one you don't have to worry about is solving for r, because r is radius. Radius is always positive. So here we can see x is going to be negative. So I'm going to have a negative. Oops, I don't want to be in green. We're going to have a negative in front. And then we are going to draw our square root sign. So put that in. And now we go straight to using Pythagoras' theorem. So hypotenuse squared minus leg squared. And remember, very important, you need to put those brackets in. Otherwise, it's just all going to go haywire. And so when we do that, put that into your calculators, and I want everyone to have their calculators out while they do this. It is no good if your friend knows how to get the answer, because in a test, your friend is not doing your calculator work for you. Okay, so we're going to get x equals negative 8. So the question is asking us for tan of beta, so we can then say, therefore, tan of beta is equal to, and we're going to say negative 15 over negative 8. But again, that's not mathematically correct, because we don't say negative over a negative, right? So I'm writing horizontally here, but remember, in a test or even in your homework, you're always working vertically. So we get 15 over 8. Another important thing, don't turn this into a mixed number. We don't do mixed numbers in high school, remember? It stays like this. The only thing you do is you simplify the fraction. So if 15 and 8 had a common factor and we could simplify, then you simplify. You don't turn it into a mixed number. You're not going to give me at this stage any decimals. We want it just like that. Okay, so if you have any questions, you can raise your hand, or if you want to come to my desk and ask me, you can do that as well. And we are going to move on to practice classwork.